Oops, can you share the screen? Otherwise, it's pointless. Okay, so we've torn out our angles. We've proven the triangle sum theorem. Oh, I do have it written down. Good. Okay. So we've proven the triangle sum theorem, which states that the sum of the measures of the interior angles of a triangle is 180 degrees. So the interior angles are obviously the inside angles. There are exterior angles of triangles. We'll talk about those in a second.
Uh-oh.
Okay. Okay. Right. Okay, accept them. They want you to go to the office instead of the library, though. Okay. Take all your stuff. Okay. Now, I want you to squeeze in there the triangle inequality theorem, which we just proved with the yarn, that A plus B has to be greater than C. Okay. So what happened is we had two short pieces and a long piece. We had one piece of yarn, let's say it was 10 centimeters long, and we had a short piece that was 3 centimeters and a short piece that was 2 centimeters. What happened is that they weren't able to connect unless they were overlapped, which there is no overlapping in a triangle. So they weren't able to form a triangle because what's 3 plus 2? Not greater than 10, right? Now, what's interesting is what if they were both 5 inches long?
It's equal to 10. So
It would equal 10, so it cannot work. The reason it wouldn't work is because they would touch, but the only place they're going to touch is when you lay the yarn on top of the other yarn, in which case now you don't have a triangle, you just have a really thick line. And so it really does have to be greater than, not equal to. It's the triangle inequality theorem. Okay. So if the two short sides of a triangle do not add up to be longer than the longest side, then you can't actually have a triangle. And so you're going to get questions in the homework and on the triangles worksheet tomorrow, where they're going to give you 3 sides of a triangle and they're going to ask you, can this form a triangle? And you'll have to add the 2 short sides together. Not the first 2 numbers they give you, but the 2 small numbers. Sometimes they give you a small number at the end, they give you a small number at the beginning, and they give you the large number in the middle. So always add the 2 small sides together. Let's keep going with these notes. Let's find the value of x. Now, when you do this, I want you to write everything in equation form. Equation form. Equation form. So I don't want to see this on your work paper. I don't want to see this on your work paper. What is that, 80? Okay. I want to see it as an equation. So I need to see this on your work paper then. I need to see you saying that x plus, and if you want to combine your like terms, that's fine, equals 180. And then I need to know what x equals. 100. That's what I need to see on your work papers. I don't want to see what you're subtracting. I want to see what it should add to. Because when you write an equation form, that's going to help you when you have multiple variables. They're not all this easy. So doing it like the way I did it originally isn't going to be super helpful when I've got x and 3x and 4x. Yes.
Macy Straub, Aiden Berkey, Dawson Stewart, Kirsten Rockwell, Ashlyn Wright. Please
No,
come
you
to the
don't
office.
have to. That's a good
Again,
question.
Aiden Berkey.
If it
Macy
says,
Straub,
what is the
Dawson
measure
Stewart,
of this missing angle,
Rockwell,
then I put a degree
Ashlyn
symbol.
Wright. Please come
If
to
it
the
just
office.
says, what is x equal to, I just put x equals 100. Okay. Yes, Max, where's your mask at? Get it on. Or I'm sending you out too.
pretty sure that was one of the problems.
Okay.
Yeah, I never read it.
Very well could be. Example B. x plus what's 81 and 25, right? Ashton?
106.
Okay. Equals 180. Again, using the triangle sum theorem, I know that all three interior angles add to 180. What do you get when you subtract 106?
174, sorry.
And again, I don't need to put a degree symbol because I'm just solving for x, just solving an equation. Example C.
Another
Hello? Okay, I'll send them down. Hi. Max Duke. Hi, Max. Yes. Example C. X plus 28 plus 90 equals 180. Or you can jump right to your combined like terms form of the equation, which would say what?
2x plus 118.
If you'd like to jump straight to this equation, that's fine. And then we're going to subtract 118. What's 180 minus 118?
162.
Okay, divide by 2.
31.
Okay, show both those steps. Okay, so when you move the 118 over, you get 62. And then we have 2x equals 62. Divide by 2 and you have x equals 31. I don't need to see any of the in-between steps. I don't need to show, you don't need to show that you're dividing by 2 on both sides or subtracting by 118 on both sides. We've solved equations all year long. This is fine. Example D. If you jump straight to the combined like terms form, you've got x and x, which makes 2x. But be careful here because you have 43 and you have negative 35. What's that make, Dylan? 8 equals 180. Yeah, because you were subtracting that 35, treat it like it's a negative 35. Subtract 8 from both sides. What do you get? 172. And divide 172 by 2? 86. Solve for x. Yeah, equation form. Yes, Carolyn.
Would you still accept it on like the work paper if we said 2x minus 35 plus 43 plus 100?
Absolutely. If you included that original equation, that's no problem. Yeah, if you want to write the original, that's no problem at all. All right. Now, you guys should have known that from last year. I teach in 7th grade math, I teach my 7th grade math students the same exact thing. Okay, that there's 180 degrees if you add up the angles of a triangle. This is going to be new though. This is the exterior angle theorem. So the exterior angles are the adjacent angles extended outside the polygon. It's not just triangles that have exterior angles, it's all polygons that can have exterior angles. So if you take a triangle, you take a ruler, you extend the sides of a triangle, and then these angles out here, all of them in this case are obtuse. That might be a few actually. All of those are exterior angles. So the triangle exterior angle theorem states that the measures of the exterior angle of a triangle, did I put that plus there? Is it in your notes? Yeah, it's probably is. I probably didn't erase it. Okay. Equals the sum of the measures of the two non-adjacent interior angles. That's a mouthful, so I'm going to repeat that. The measure of the exterior angle equals the sum of the measures of the two non-adjacent interior angles. That means this exterior angle equals the sum of the two non-adjacent interior angles. Adjacent means next to. Non-adjacent means not next to. So I'm looking at the two angles opposite from that exterior angle. So this angle here doesn't come into play. We mentioned that, remember when we actually looked and when we ripped out our angles and I said if you put your two ripped out angles, then they formed a giant angle D. that the two ripped out angles form this angle to make a straight line. So the two non-adjacent interior angles, A and B, equal angle D. So that's new, but that's not very difficult to use. I'll show you how we can apply that to this first example. The exterior angle equals the sum of the non-adjacent interior angles, 36 plus 72. What's 36 plus 72? 108. So that exterior angle, being the sum of those non-adjacent interior ones, is 108 degrees. Again, oh, this one says find the measure of that angle. So I am going to put degrees. Anytime it asks for specifically the measure, I want to label it in degrees. Angle B, or sorry, number B, letter B, whatever it is. Okay. The exterior angle equals the sum of the two non-adjacent interior angles. So what's 40 plus 30?
70 degrees.
So y equals 70 degrees. Example C. The exterior angle 2A equals the sum of the two non-adjacent interior angles. So 80 plus A minus 5. Combine your like, yeah, Ashton, you have a question?
Can you check it by adding them all together to get 180? Or is that not?
You can check it by adding it with this angle if they give it to you to make sure it equals 180. Or you can just double check your math and make sure that these two equals this one again. Okay. What's 80 and negative 5 make, Riley? Okay, wait till I call, please.
And couldn't you combine the A on the other side to get?
Yes, we are going to. I'm going to go ahead, since I'm combining my like terms, I do that in a separate step. And then anytime I'm moving things over to the other side, I do that in a separate step itself. So I am going to go ahead and move that A over to the other side by subtracting A from both. So if I subtract A from this side, it's gone. And if I subtract A from the 2A side, I get A. That's what you were saying, just in the opposite order. Yeah. So we should get A equals 75. So again, I subtracted A from both sides to get 1A equals just 75. Now, the instructions of this said find the measure of the exterior angle. The measure of the exterior angle isn't 75 degrees. The exterior angle was 2A. So if A is 75, what's the measure of the exterior angle? 2A is 150 degrees. Yeah, we didn't have to worry about that on example A and B because it was just X and it was just Y. But this is 2A, and this one is 4n minus 20. So I'll have to, again, once I find n, I'm going to have to then solve that expression. So my exterior angle, 4n minus 20, is equal to the sum of my two non-adjacent interior angles. So n plus 2n plus 20. Or if you want to go ahead and combine that to 3n plus 20, that would be the obvious next step.
So if we were like on the one like number B.
Yeah, on B?
Yeah. Can we just combine them, or do we have to write y equals 30?
I'd like you to write down those two angles and just write y equals 70 degrees then. Okay, instead of just write an answer down, you could say, even if you don't have to use a calculator, you could still write 40 plus 30 is 70. Now, we got to move, it's been a while since we've had equations with variables on both sides. We've got to move constants to one side. We've got to move variables to one side. So let's start with our variable terms. Let's move the 3n over. I don't know, it's been a while since we've done equations, but you guys remember we like to keep that variable term positive, right? If I move the 4n over, I could do that. It's just going to make it a negative, and I don't want my answer to be negative. So I subtract 3n. I'm going to get just 1n. Of course, that's gone. And I have to, if I've moved my variable to the left, I have to move my constant over to the right. How do I get rid of a negative 20? Elise? Excellent. Okay, so that's gone. And then what's 20 plus 20, Elise? 40. So n equals 40. Now, let's answer the question. If n equals 40, Elise, I'll let you answer this. If n equals 40, then I want you to tell me what 4 times 40 is. Minus 20. Yes, so that exterior angle would measure 140 degrees then, okay? An airplane leaves from Miami and travels around the Bermuda Triangle. Back in the day, before we had GPS, there was lots of ships that would get lost and sink in this triangle. I don't know why, if it was just a prone for storms or what it was, but it's kind of a graveyard of ships. It's a portal. It could be. I've never been there, so I can't say it hasn't. It's not a
Well,
portal.
there's a guy that flew a plane through there.
Is this the triangle sum theorem or the triangle exterior angle theorem coming into play? Yeah, I don't see any exterior angles. So I know that all the angles in a triangle add to 180. I'm going to combine my like terms. What's x and 2x? And what's 62.8 and negative 44.8?
18.
18? Positive 18 or negative 18? Positive, good. And that's going to equal 180. Again, if you want to just write it all out and then simplify it to this, that's fine too. Subtract 18 from both sides. Okay, divide it by 3. Okay, did it say find all the angles or did it just say find x? So we're done. If it said find all the angles, we'd have to plug x in right there, times by 2, subtract 44. Okay. 54, because it just said find x. If it says find the measure of an angle, that's when we measure it in degrees. The measure of two complementary angles has a ratio of 3 to 6. What is the measure of each angle? I feel like we did one like this yesterday. What does it mean that they're complementary? Dylan?
They add up to 90 degrees.
Yes. So I'm going to start with x plus x equals 90. Because they have a ratio of 3 to 6, I'm going to call this one 3x, and I'm going to call this one 6x. And what's 3x plus 6x equal to? 9x. And what's 90 divided by 9? 10. Now, I haven't answered the question. It says, what's the measure of each angle? So let's start with the 3x angle. If x is 10, what's 3 times 10? 30 degrees. And then let's do the 6x angle. If x is 10, what's 6 times 10? 60 degrees. Check your work. Does that add to 90? Okay. So if you see questions where they ask you to use ratios, that's an easy way to do those questions. Call them both x and then call one 3x and the other one call it 6x. The measure of the second angle in a triangle is 4 more than the measure of the first angle. And the measure of the third angle is 8 more than twice the measure of the first angle. Find the measure of each angle. It's a lot. Well, there's 3.
I know, but they say angles.
They do. They do. Okay. So it said, let's start by calling the first angle x. I don't know what it is, but they keep referencing that one. So let's just call it x. I know that if you take the first angle and add it with the second angle and add it with the third angle, it's all going to equal 180. The second angle, it says, is 4 more than the measure of the first angle. So how do I write that? Okay. Yeah, you can't just write plus 4. You have to write x plus 4. Because if the first angle is 10, this one can't be 4. It's got to be 14. So you have to put x plus 4. So we've got our first angle. There's our second angle. Our third angle is 8 more than twice the measure of the first angle. So how do I write twice the first angle, Riley? Okay, and how do I write 8 more than that? Good. So I've got all 3 angles accounted for, and now I can set equal to 180. So this problem isn't as complicated as it looks on the surface, where it's very wordy. But once I write it down, there's a lot of stuff that combines. Riley, go ahead.
4x plus 12 equals 180.
Good. Subtract 12 from both sides, Riley.
168.
Good. And what's 168 divided by 4?
42.
All right. It says find the measure of each angle. So since angle 1 is just x, I know it's 42 degrees. I know to label it degrees because there's the word measure. What's 4 more than 42? Okay, so angle 2 is 46 degrees. And then what do you get if you take 42 and double it? 84, and then add 8.
92.
92. I'll take it one step further. Let's classify that triangle. Is it acute, right, or obtuse? It's obtuse. To be obtuse, you have to have one angle that's larger than 90. We do. Is it scalene, isosceles, or equilateral? Because all the angles are different, all of the sides are going to be different, and so it is obtuse. Scalene. That didn't seem like I spelled that right. That looks good. Okay. All right. And let's tell you what, why don't we hold off till tomorrow on those? It's already 2:02. We'll hold off on, no?
Yes. No.
Everyone but you.
No, I actually did it.
You should just.
I'll tell you what. Use the restroom and then come back and we can write these down. Since they are homework, I'm letting you work on homework. Okay. Go ahead and use the restroom and then we'll work on these together. You can recycle. You can recycle scraps. Including the triangle. It's a scrap at this point because you ripped off the angles.